Hello everyone, in this video let us solve this question. So we have a raised to power a is equal to 7 and here we have to solve for the value of a. So a is the unknown we have to solve for. Now to do this, solution. So we have a raised to power a is equal to 7. Now this question is that you will pick a particular number and raise that number to that same number and the value must equal 7. So let's say we try it out, we test it. We test number 1, 1 raised to power 1. This is equal to 1 and it is not equal to 7. If you try out 2, 2 raised to power 2, this is equal to 4 and it is not equal to 7. Try out 3, 3 raised to power 3, this is equal to 27 and this is not equal to 7. But if you observe closely, you will see that the number 7 we are looking for is in between 4 and 27. That is in between 2 and 3. So this means that the value will not be a whole number but a decimal number, something in the form of 2.1, 2.2, 2.3 thereabouts. But it will be much more stressful for us to get the exact value. But there's a much more easier way for us to do this. So just follow. So right here, to solve this, first, we're going to introduce natural logarithm to both sides of the equation. So ln a raised to power a is equal to ln 7. So with this, we are then going to apply this rule of logarithm, that if you have logarithm of a raised to power b, this equals b times logarithm of a. So applying this property of logarithm or natural logarithm right here, power a then becomes a times ln a is equal to, here we have ln 7. Now at this junction, in order for us to solve this further, we are going to introduce a particular function called the Lambert W function. So we call it the Lambert W function. Now this function is that if you have an expression of this format, a times e raised to power a, once you apply the Lambert W function to this expression w, what you will get as the value will be a. Same thing also, if you have 3 times e raised to power 3, if you apply the Lambert W function w, what you will get as the value will equal 3. So in this case, we are going to manipulate this to resemble this expression such that we can then apply the Lambert W function. Now to do so, first we are going to introduce a particular variable, and the variable is this. See, if you have e raised to power ln x, this is equal to x. Why? Because if we cancel ln, x will stand alone. So therefore, if we have e raised to power ln a, this is also equal to a, because if we cancel ln, a will stand alone. So in replace of a right here, we can bring in e raised to power ln a. So this then becomes, we have it as e raised to power ln a, then we have times ln a is equal to ln 7. Good. So if you observe this expression very well, you see that e is in the second place. So move this e to stay in the second place. We have ln a times e raised to power ln a is equal to ln 7. Such that with this, we can then apply the Lambert W function. So W into brackets is equal to W times ln 7. Such that with this, once we apply the Lambert W function to this expression, what we get as a value will equal ln A is equal to W times ln 7. So from here, to then solve for the value of A, the next thing for us to do is to remove this ln from here, and to do so, introduce E. So e raised to power ln A is equal to e raised to power W times ln 7. With this, if we cancel ln, A is then equal to e raised to power W times ln 7. So we've gotten the value of A to equal this. But then if you are confused as to why the value of A is not a numerical form, Don't be confused. Simply press in your calculator the value of A is equal to, you will see in your calculator, press E, then raise to power. Sometimes you will not see W, but instead you will see product log. So type in raise to power product log, then multiply it by ln 7. So if you type in this in your calculator, what you will get as the value of A will equal 2.3165 in 4 decimal places. So this means that if you raise 2.3165 to 2.3165, you will get the value to approximately equal to 7. So with this, we have gotten the value of A that will give us 7. So I hope you all enjoyed the video. Don't forget to like this video, subscribe to this channel. Thanks for watching. See you in the next video. Bye.